Hi everyone, today I will talk about the customer predictions on subscribing to a term deposit using machine learning. So term deposits is an important source of stable funding for banks. The banks will use direct marketing, which is the banks will promote product directly to the customers. However, contacting every customer without considering their percentage of subscribing will lead to high operational costs, inefficient use of marketing resource, and also low campaign success rates. Therefore, the objective of this project is to develop and evaluate machine learning models to predict customer subscription to term deposits. We will use logistic regression, random forest, and also artificial neural network, ANN. So the dataset used in this project is bank marketing dataset full downloaded from Kaggle, which is from a Portuguese banking institution. So the dataset type is a structured tabular data. It is used for binary classification tasks and contains of more than 45,000 entries with 17 attributes. 7 of it is numerical and 10 of it is categorical. So here are the feature description. And y will be our target variable. Okay, so there are some potential data quality issues. The first one is class imbalance. So the target variable is highly imbalanced, where 88% of the customers are not subscribing to a term deposit. Next one is categorical variables, like job, marital, education, that cannot be directly processed by machine learning models as they cannot process text. Next one is feature skills difference. So numerical features has different range of values, like age range from 18 to 95, while balance range from negative to 100,000. Next one is missing values. So in Kaggle, the dataset shows no missing values, but you also need to check later. And the last one is duplicate values. Duplicate records may happen due to repeated data entry process. So now we will move on to the exploratory data analysis, EDA. So it's important to check the missing values and duplicates before EDA, as it will affect the accuracy of the analysis and may lead to wrong conclusions. This is the descriptive statistics. This one is numerical feature summary. So this table shows the mean, standard deviation, minimum value, value of each quarter, and maximum value of the numerical feature. And this is the categorical feature. So it shows the unique types of number, unique types of answer, highest counts of unique answer, and the counts of the highest unique answer. So now we move on to the features distribution. This is the numerical features distribution. You see that the age is a bell-shaped distribution, while the balance, duration, campaign, p-days, and periods is right skewed. Okay, now we move on to the count plots for categorical columns. Here are the count plots of it. You can see, like most people's job is the blue collar, and most of the customers is married. Okay, now we move on to the correlation analysis. So from this correlation matrix, we can see that there are weak correlation between the numerical features. The highest one will be the p-days and the previous, which is 0.45. So this means that most of the features is distinct information to the model. We will give distinct information to the model. So next is the class distribution analysis. So we can see the target variable is really imbalanced. So other than accuracy, the precision, recall, advanced score, and area under curve will also need to be considered for model evaluation. So we move on to the data preprocessing. So first we need to check the missing and duplicate values. So there are 0 missing values and 0 duplicate values. So next we will need to do the normalization to reduce bias to the model. And we need to count the unknown values, as the unknown in this dataset may provide useful information. Next one is target encoding. to convert the target variable into a binary format. 1 is customer subscribe, 0 is customer did not subscribe. Then we will separate the features and target variables to prevent data leakage and also ensure that the models learn meaningful relationships from customer characteristics rather than directly accessing to the prediction outcome. Next, we'll be identifying the numerical and categorical features, means separating the features out. Then next one is splitting the data set. 80% will be the training set and the 20% will be testing set. So here, for numerical features, we will apply feature scaling, and for categorical features, we will apply one-hot encoding. So numerical features will standardize to have a mean of 0 and standard deviation of 1. To prevent the model treats particular features more important just because they have a larger value. Then one-hot encoding is used because the machine learning models cannot directly process text. So now we have 51 features instead of 16. Then we handle a class imbalance. We use the class weights. Then we move on to the feature engineering. We use feature selection, where we select the top 20 informative features from the 51 features. So you can see here is the feature scores of the top 20. And this will be our final dataset. And we reduce the dimensionality of the dataset from 51 features to 20 features. So we move on to the model development. So this is a binary classification machine learning task, as the target variable has only two answers, which is subscribe and did not subscribe. It is supervised learning because it contains input variables and output variable, which is the target variable y. It is classification because it predicts categories, which is yes or no. Okay, so move on to the first model, which is logistic regression. So logistic regression investigate the hyperparameter C. So C controls the amount of regularization applied during training. So here we use 0 0.01, 1 and 100 of the C values. So here we can see the C value of 100 has the highest accuracy, precision, recall, F1 score, and area under curve. It also has the lowest training time. So here is the visualization. You can see that it has the highest F1 score for the 100 C value. Here's the confusion matrix. It predicted correctly 6,000 plus the customer that did not subscribe and 839 customers that subscribed. So the working principle of logistic regression is a supervised machine learning algorithm used for binary classification, and it applies sigmoid function to linear combination of input features. So the advantages of logistic regression is it is easy to understand and interpret, while also have fast training and prediction. It also performs well with linearly separated data and cheaper than complex model. The limitation is it assumes a linear relationship between features. Therefore, it cannot naturally model complex nonlinear relationships, and the performance will decrease if there are important interactions between features. Next one is why logistic regression is suitable? Because the dataset is structured tabular data that contains numerical and categorical features. So after feature selection and one-hot encoding, it can provide effective baseline model that is computationally efficient and highly interpretable. So the strength of logistic regression is it has high interpretability, fast training time, and good baseline performance. Its weakness is it has a lower performance to model nonlinear relationships compared to random forest and ANN. The next model will be random forest. We use the hyperparameter of n estimators, which represents the number of decision trees in the forest. So here we use 100, 300, and 500 trees. So as the result shown, you can see that The 100 trees has the highest accuracy, precision, recall, advanced score, and area under curve. It also has the lowest training time, so it's the best performance model. So we can see here. And in the confusion matrix, you can see that the model predicted 7,000 plus correctly that customer did not subscribe, and 366 customers that subscribe. So random forest is a supervised learning algorithm used for classification and regression tasks. So instead of building a single decision tree, it contrasts many decision trees. And for the class receiving the highest number of votes, will become the final prediction. And so the advantages of random forest is it has the ability to capture non-linear relationships. It is less prone to overfitting than a single decision tree, and it can handle both numerical and categorical data effectively after pre-processing. The limitation is random forest is more computationally expensive due to the construction of multiple decision tree, and it also more difficult to interpret. Larger model will also need more memory and training time increase. So why random forest is suitable? Because customer subscription decisions can be influenced by age, account balance, previous marketing campaigns, and so on. The relationships may be non-linear, and random forest can handle non-linear relationships well. So the strength of random forest is it can achieve higher performance than logistic regression, and because it can model complex non-linear relationships, and also requires less hyperparameter tuning than ANN. However, it needs more training time than logistic regression. Last one will be ANN, artificial neural network. So since the multi-layer perceptron MLP does not support class weight, so we need to use mode to handle the class imbalance. So the hyperparameter used here is hidden layer size, represents the number of neurons. So we choose to use 32, 64, and 128 neurons. This is the result. You can see that 128 neurons has the highest accuracy, precision, and advanced score, but has the longest training time. It is considered as the best performance model here. So you can see here the advanced score of each neurons, each number of hidden neurons of the model. So this is the confusion matrix. So it also predicted correctly 700,000 plus of customers that did not subscribe and 664 customers subscribe. So ANN is a supervised learning model that is fundamental of deep learning systems. And NLP also consists interconnected neurons organized into one input layer, one or more hidden layers, and one output layer. So each neuron receives input values, multiply them by learn weights, add bias term, and pass the result through activation function. So ANN can capture complex neural relationships between features and target variables. It can learn the feature interactions automatically. It is also a flexible architecture that can adjust hidden layers and neurons for different situations, so it can achieve higher performance. So the limitation is ANN is less interpretable as learn weights do not give explanations, and it takes the longest training time. Also, the performance is also dependent to the appropriate hyperparameter tuning. So why ANN is suitable here? Because the dataset can have non-linear relationships and can be complex. Or ANN is suitable in this situation, as it can automatically learn those complex patterns. Feature scaling and one-hot encoding is also done in this project, which is suitable for neural network training. Then the strength of ANN model is it can achieve higher performance than logistic regression. and can perform similarly or better than random forest in non-linear interactions. However, it takes the longest training time and has the worst interpretability compared to other two models. So move on to the model comparison. You can see that random forest has the highest accuracy and the ANN has the highest F1 score. So the computational cost, you can see that logistic regression takes the least training time and ANN takes the longest training time. Okay, so after comparing the performance of the three machine learning models, we conclude that random forest is the most recommended as the final model to predict whether customers subscribe to a term deposit. Although logistic regression has the highest interpretability and lowest computational cost, its linear assumptions limited its ability to capture complex relationships. ANN has strong performance, but also needs the longest training time and also needs appropriate hyperparameter tuning with a least interpretable model. Random forest is overall the best one in performance, robustness, training time, interpretability, and operational feasibility. It has the highest accuracy and a slightly lower F1 score than ANN, but has a way faster training time than ANN. You also can learn nonlinear relationships better and reduce overfitting through majority voting. So, although random forest has a longer training time than logistic regression, it is acceptable for a dataset of this size. Model also demonstrate the strong generalization ability and robustness to noisy data, making it suitable for practical deployment. Therefore, random forest is recommended as the final model. That's all. Thank you.